Hello everyone, my name is Rivan Chandrayamasi and I am here to present my video demo for the final project. Firstly, I'll be briefing about my project and then I'll demonstrate it. So speaking about it, my final project is named Fraudshield. It is a web-based credit card fraud detection system whose main purpose is to identify suspicious credit card transactions using machine learning and CSV based batch prediction. This system allows its users to create an account as well as verify it with email and train train a fraud detection model as well as upload transaction CSV files to predict and view the summaries as well as download them in our PDF report. And it is based is a user based project where not all users are able to access the every feature of the website. Speaking about the project, it combines two parts. First being the research and machine learning stage where the model is trained and evaluated, and the second part being the web application stage where the model is trained and used inside a Flask based application. So speaking about the aim of the Fraudshield and the problem which it is made to solve. It as the name says, it mainly focuses in credit card fraud detection. As we know, in the real world financial systems there are many normal transactions done, but some of them can be fraud, which may lead to a huge loss for the bank as well as users and customers. So speaking about the project system roles, system the project's users and the roles, it is mainly divided. It has four roles. Firstly being the demo role, then the admin, then the analyst and the viewer. So speaking about the demo user, it is an account where the user can briefly where the user can log in and see the features of the website. The second and main role being the admin, who has the higher control, as admin can not only train and predict but also manage the users, change the users role, that being from analyst to viewer or viewer to analyst, and as well as activate or deactivate the users. But the admin itself cannot change its user, as it is protected, so that it cannot be changed accidentally. You can see the users on the use case diagram, which I have done, which I have kept not only on my report but also in my presentation slides. uh, Second, the use case diagram. Here it is. It's a use case diagram. Uh, Now talking about the technologies that I have used here. For the web application, I used Flask as the back-end framework, as Flask and as Flask in this project specifically handles the routing, user login, database, dashboard pages, model lab pages, profile pages, and as well as the admin user management as well. For the database, I have used MongoDB. Right here you can see, as it stores the user account, roles, account status, the login details of the user, profile details of the user, and as well as the training and prediction history. For the machine learning part, I used Python machine learning libraries such as pandas and numpy. uh, Here it is. Here are the codes in R which I have used in this project. You can see. For the machine learning part, as I said, I have used Python machine learning libraries, which are used for CSV files, for the cleaning of the data, training models, and evaluating model performance, as well as save the trained model. And finally, for the front end, as you can see here, I have used HTML templates and CSS styling and charts to make the system let's say more readable for the user. Talking about the research and mm, dataset part of this project, the dataset used in this project contains credit card transaction records, where each row represents one transaction, and the class, that is column, identifies whether the transaction is legitimate or fraud, that being 0 means legitimate transaction and 1 being the fraud one. And in R and machine learning stage, the dataset is loaded and checked for missing values, and it is converted into the right format. Now talking about the data preprocessing and feature preparation. After loading the dataset, the next stage is feature preparation, which means preparing the input columns so that the machine learning model can understand them properly. Uh, uh, and talking about the feature pre preparation, it is also important because the model should receive the same input structure during the training and prediction. Now let's talk about the training and test. After pre-processing, the data is divided into two sets, that being training and testing. Training set is used to teach the model the relationship between the transaction features and fraud levels. The testing set is kept separate and is used for checking how well the model performs on scene data. And talking about this step, it is important because if we test the model on the same data it was trained on, the result may look better than it actually is. By using separate testing data, one being for training and one being for testing, as I said, we get a more realistic idea of model performance. uh, you may also think that there could be imbalanced data for this project. I had also faced it before, but it was a challenge as well. As we know, fraud cases are comparatively fewer than legitimate cases, and if the model is trained directly on this type of data, it may become biased towards legitimate transaction. To handle this, with the help of my supervisor, I tested different sampling techniques, that being random oversampling, random undersampling, combined sampling, and SMOT. Random oversampling was done to increase the number of minority fraud samples. Random undersampling was done to reduce the number of majority legitimate samples, and combined sampling used both approaches. Smooth created was done for creating synthetic fraud uh, to help the model run fraud patterns better, you can say. The R implementation was done to train and evaluate decision tree models with ROS, RUS, combined sampling, and SMOT. Uh, then the results were compared and using fraud focused evaluation metrics. Now talking about the candidate algorithms. For model selection, more than one algorithm was considered before choosing the final model. This particular project considers algorithms such as logistic regression, decision tree, random forest, supported vector machine, and his gradient boosting. Random forest was included because it is an assembly tree based model and is useful for tabular classification, you can say, while variant boosting is also included because it is a strong candidate for structured tabular data, you can say that. And the purpose for comparing different algorithms is that as we know, each model has different strengths. Some models are easier to explain as well, while some handle nonlinear patterns better and some perform better on complex ones as well. The strongest model is selected based on how based on performance metrics, you can say, and it is then saved for the deployment. Now let's talk about the evaluation metrics. For evaluation, normally only accuracy is done as far as I thought, but with the research I had done, I was able to know that accuracy is not accuracy on its alone is not enough, as accuracy shows the overall number of correct predictions, but in this particular fraud detection, accuracy alone can be misleading as well. A model might predict most transactions as legitimate and still get high accuracy, but miss some fraud cases which may lead to bad outcomes, as we know. So no, so I used not only accuracy but precision, recall, F1 score, and ROC AUC. Precision was used as it tells how many predicted fraud cases are actually legitimately fraud, whereas recall tells how many real fraud cases were detected, and F1 score balances the precision and recall, whereas ROC and AOC helps compare classifications performance across the threshold. Now let's talk about the model artifacts and deployment collections. After training and evaluation, the important outputs are saved as model artifacts. The main model file is fraud based model dot joblib. This which stores the selected trained model so that the system can reuse it inside the Flash application for later as well. The second file is feature column.json, which keeps the expected input column order. So when a user uploads a new CSV file, the system can check the file like that if the file matches the required structure or not. The third file being metrics.json, which stores the model evaluation system and summary performance values as well. These artifacts connect the node, or you can say research states, to the product stage. Without these saved files, the web application would not exactly know, we can say, which model to load or which input columns to expect. So now I'll start my demonstration. So firstly, here is my website. I have logged in as this account, which is an analyst. So you can see as I open the model lab, I can train and predict it. I have already trained, so I'll be predicting. I will be selecting this one and doing the prediction. As you can see, here is the summary, and here is the it has detected which of the transactions are fraud, which have the high risk and which have medium. Scrolling medium as well as blue ones. It also states why these are predicted as fraud and the reasons why. As you can see, high amount, unusual transaction pattern, customer profile mismatch. Now not only that, but the analyst can also download the summary PDF as well as the detailed PDF. Here is the detailed one. And here is the summary. uh, this is the analyst, as I said. Now let's log into a viewer. This is a viewer account. As you can see here, I have logged in as a viewer. When I try to open the map, as you can see, I cannot train it, but I can predict one. Let's predict it. There we go. But the viewer cannot download the PDF reports, as it is only restricted for the admin and analyst. Let's try to do this one. As you can see here, analyst. Now I would like to show what happens when we create an account. So let's go to the create page. I will type the new mail here. You can see we can send the OTP as well as resend it. So now let's see if it was sent or not. So I'll refresh it. As you can see, it was sent, and you can check here as well, the OTP has been received. So with this, I would like to end my video demo, and I look forward to my physical demo as well. Thank you.